computer science is the magic of building something useful. It's a very boring way of saying, if you find something that you really want to build, you will go to the end of the earth to build it.
Hello there, and welcome to a new episode of the Easy EdTech podcast. If we haven't met before, my name is Monica Burns, and you are joining us today for a special bonus episode of the podcast in partnership with Hatch Coding. I'm excited to bring you another special bonus episode on a Friday, and if you're used to joining us on Tuesdays, you are in for a treat today. We have another great conversation about a topic that may be front of mind for you, or maybe moving towards the front of your mind after you finish this episode. I am a former New York City public school teacher. I've been out of the classroom for several years now, leading professional development for educators and writing about all things ed tech on my blog, classtechtips.com. And I love connecting with people who are passionate about ed tech for conversations like the one you're about to hear on the Easy EdTech podcast. Before we jump into today's episode, a quick reminder. You can head to my website, classtechtips.com/podcast for all of the show notes and resources from today's episode. And if you're listening to this on a podcast player like Apple Podcasts or Spotify, you should see a link in the description. You can click on it as you're listening today, and it will take you to all of the resources I mentioned. Today's episode is brought to you by Hatch Coding, where they empower tomorrow's innovators by teaching coding and AI to students ages 8 to 18. Hatch Coding is like a secret society, except their secret handshake is coding, and their students go on to build the next big thing. Hatch's engaging interactive platform offers 450 hours of learning in Python and JavaScript, but fundamentally teaching the language of the future. Discover more at hatchcoding.com /Monica. That's Hatch, HATCH, coding.com /Monica to unlock a 50% discount for your first month. Welcome to the podcast. I'm so excited to chat with you about this concept of debunking common misconceptions about teaching coding. But before we jump in, can you share a bit with listeners? What is your role in education? What does your day-to-day look like?
Sure. So I'm a CEO and co-founder of Hatch Coding. I co-founded with my wife, who's a professional educator since 2005. And basically, I am building a 450-hour curriculum for learning computer science, right? So if in math, there's a well-trodden pathway between 1 + 1 and calculus, we're trying to build that for computer science.
I love that example, right? We think about curriculum and the pathways that students take, right, in all different subject areas. And so as we talk today about coding, computer science, right, all of what that can mean in a classroom, in a school setting, would love to unpack some of these common misconceptions about teaching coding. If you had to narrow it down to just a few, what are some of these common misconceptions about teaching coding in schools?
Sure. So I think the first two misconceptions are about who you need to be as a student and who you need to be as a teacher. So, as teachers, what my wife likes to say, how do you know that you're teaching history in September? Well, the principal in June says, hey, listen, you're teaching history in September. It's not that you need a degree in history and then a degree in geography and then a degree in English to teach those three topics. It's more like as a teacher, you have to be a practitioner of learning the material and sharing with other people. So the first misconception is you do not need to have a deep background in computer science to teach computer science, because your job as a teacher, the practice of a teacher, is to take in information and then share it with students. And the second one is who you need to be as a student to take computer science. So I think that we can all imagine in our head the image of the nerdy robotics, chess loving, math competition geek. And that you don't need to be that person to do coding. Today, when you get into the real world, there's design oriented coding where you're basically just doing interior decorating, just using code, which means you need to be more creative and have a sense of spacing and proportions more than you need to know really complex math. There is the complex math. Obviously, if you want to do self-driving car algorithms, there's probably more math involved in that. But coding is basically just logic. So if you can take philosophy 101, which almost anybody could take philosophy 101, there isn't a lot of, hard core science stuff to that. You can do coding. So those, I think, are the first two. And I think the third one that I would say is the way to get good at coding is to pick projects that are interesting to you. So, computer science is the magic of building something useful. It's a very boring way of saying, if you find something that you really want to build, you will go to the end of the earth to build it. So I became a software engineer at 12 when I had a problem to solve. I was totally nerdy. I loved Dungeons and Dragons, and I hated rolling dice. And this is a problem that needed to be solved. And I had gotten a new computer, and I solved it by building an app on my computer to create my characters for me. And that's really the key to launching your career in tech, is finding something that you really want to build. It could be something Harry Potter related, or it could be a to-do list app, or it could be a scheduling app, or it could be something for bicycling because you just love to bicycle. Whatever it is that would really inspire you to go to the ends of the earth to make it work well, that's what you need to get good at coding.
And those are such important things that I think we all struggle with, right? We've been to the movies, we've seen these visions, right, of what a coder is, or what someone who would teach coding might look like or say or be interested in. But it really comes back to that passion or having a problem to solve or knowing that you want to tackle a particular task. So I think those are such great misconceptions for us to move away from, that you have to be a certain type of person or fall into a certain type of category or bucket. And that as long as you are really interested and excited about something, right? And I want to ask you a little bit about what some examples might be, right? In addition to your own there, right? That can really help get someone interested in and excited in this topic. So, for many of us, in this technology space, we like to work to accomplish a goal. We have projects that we're passionate about. You shared the Dungeons and Dragons app building example. I know from my standpoint, I've spent a lot of time trying to make connections between tasks and my task manager, or making sure my website looks just right. Can you share a story of a student whose interest in coding was ignited by a personal project?
Yeah. So there's a person at Hedge Coding. Her name is Samantha, and she's, I think, 12 years old right now, and she really loves art. She just loves art. And she used coding to create this type of art called generative art, where basically you can use coding commands to generate a different version of a piece of art every time you press refresh. So for example, pick a random color. So you could have, a house, and the house is painted a random color. And every time you run the program, the house is going to get painted a different color. But you could do this with ice cream cones. You could do this with geometric figures. You could do this with airplanes. You could do this with different building heights, right? You're going to draw a building, but the number of floors that you have is based on the code randomly generated. And so she really got into coding, very, very good at writing like multi-hundred line coding projects that were all about creating these very complex generative art projects that, it's really remarkable.
I love that example because we don't always associate art with coding, right? Or art with computer science, right? Skill building. So I love that example of a student who saw something they wanted to do, something they wanted to accomplish, and were able to create something that I'm sure they could share and show off and are super duper, super proud of. So, why is it important for students to understand the why behind their coding projects?
I think the biggest reason is if you care about what you're building, you'll just go a little bit further, right? So let's say you're into sports and you really love basketball, but you're not really into lacrosse. And I ask you to build a sports simulation that's a lacrosse simulation. You'll do it maybe because it's part of school, but you won't be really excited. But if I give you the exact same project, but I just say, now make it a hockey simulation, and you know everything there is to know about hockey, you will spend that extra hour or 5 hours or whatever to make it the most amazing simulation you can, just because it's important to you.
That's such a great example because I think we've all spent time, not only in our own practice, but working with students, right? Who it's just that one thing, right? It's that you've set that why, right? You've established that for them. And now they are ready to do, right, that extra beat, right? The extra piece, right? The extra 10% of their time, right? The extra couple hours for that project because they're bought in, right? And they see that this is important and valuable and really worth their time. So how can educators incorporate creative project-based learning into their coding curriculum?
I think the biggest way that they could do is to give a coding project, which is a set of requirements, which is just English language, and you leave it up to the student how they're going to code that, right? And you could even provide some variety in those requirements. So if I tell you that I want to build, an animated Ferris wheel, and I would like it to have lights in the background, it needs to be nighttime, and it needs to spin at a reasonable speed. Those are all requirements for a Ferris wheel. Now you can code it any way you want. And some people might end up with really small Ferris wheels or large Ferris wheels, ones with like 2 sets of seats or 1 set of seats, right? People might really focus on the background and the details, or they might focus on getting the physics of the Ferris wheel to be exactly right. And so it's requirements-based programming, which is basically turning ideas into code. If you give kids a bunch of ideas based on whatever coding concepts they already know, and that then create the final project, that's how I would do.
So that connection between giving kids, right, a clear structure, but then the space, right, to go off and make this their own, I think comes back to so much of what I hear when talking to educators about the importance of choice, right? Of giving kids the opportunity to really voice what they're interested and excited about. So I love that as a way to set up a project that might go in a few different directions for a group of students. Now, Peter, you mentioned the generative art project that Samantha was working on. And I want to ask you a little bit about AI, right? Specifically generative AI. How do AI tools like Copilot and ChatGPT change the way we should think about teaching coding? What skills should educators focus on to prepare students for this future of, what's being called AI assisted coding?
So I think the biggest thing is today, like 60, 75% plus of professional software developers are using an AI tool to help them code. So where we are today is like in the real world, people are using these tools. So we should teach students, where the puck is going. And what happens when you use AI is it will generate so there's a couple ways that you can use AI. First of all, you can ask it to generate code for you. And if you do that, you can just imagine that they're the intern.
Yeah.
The AI is the intern, and they're just going to create a very poor quality version of what you actually want, but it's a starting spot.
Yeah.
And then the other way is if you have some code that's not working and you ask AI to fix it, AI is really good at taking a look at code and saying, hey, a bracket is missing here, or you should have a semicolon there, because it knows the structure of what the language is. So rather than spend 40 minutes banging your head against the keyboard, how do I fix this bug? You can actually just ask, ChatGPT or Claude or another tool, please fix this code for me. And it will fix it for you because it's very good at that.
And, I think we can almost add that idea of AI will replace coders to our list of myths that we're debunking here with those examples that you gave, right? The same way that I know I've spent time in generative AI spaces, getting ideas, right? Or reviewing work, right? It sounds like these are 2 areas where you might get that first start. Maybe it's not 100%, but it's 70% of the way there. And then you can also use it to review resources. So that assistant piece or that AI assisted piece, I think makes a lot of sense if you're in this space and you're looking to make the most of these tools. And you mentioned not just ChatGPT and Copilot, but Claude, right? There's a few different ones, right? That can help tackle these tasks. So, if you're talking to an educator who maybe is hesitant to incorporate AI tools into their coding lessons, what advice would you give them?
So the first advice I give is take a look at history. At one point in time, we did math with an abacus, and then we did math with a slide rule. And now we do math with the calculator. And we don't do math with the calculator in grade 4 and 5. We teach people the fundamentals of how math works. But once you get to grade 7 plus or 9 plus, for the most part, it's like, listen, if you need the tool for this problem, just use that tool, and it'll just make you more efficient. But if you don't understand how trigonometry works, no calculator will really help you.
Mm-hmm. Yeah.
But once you understand how trigonometry works, a calculator will just make you more efficient. So instead of having to spend 15 minutes to calculate some trigonometry ratio, you just type it into a calculator and you get the result. You still have to learn the knowledge of how trig works. And I think the same thing is true in coding is if you want to be truly creative, you want to build something new in coding, which doesn't exist currently, you have to apply your human ingenuity and creativity to that. And no amount of AI is going to fix that. AI can, point you in the right direction. But for example, very often when you're writing, right, with pen and paper, you'll write a sentence and that sentence will make you think about something else. And your second sentence only exists because you start to think about the first sentence all the way through the essay. And then your work at the end is an original piece of work that you couldn't really ask a ChatGPT to create because you'd have to stop at every sentence and say, now that you have this, think about this. And it's your ability as a human being to bring in other ideas into your writing or into your coding that creates the creativity and the spark. And I think that's what teachers who are hesitant to incorporate AI can think about is even after you use all this AI, if you're just asking your kids to do rote exercises, then obviously it's going to collapse, the time needed to do that to zero. But if you're asking your kids to do creative exercises, AI will only help your kids be more efficient with their time and therefore to build more creative things.
I love that trigonometry and calculator example, right? Like I've been sharing so much about generative AI with educators this past year. And I keep saying like, it's a blank space. Like it's not going to do anything for you unless you ask it for that help. And you really need to leverage your experiences, your expertise, what you know about the topic to even formulate, right? A question, a prompt, a task for these spaces. So I think that's such a great example for someone who's maybe a little hesitant to bring an AI tool into a conversation, right? On coding, right? Or computer science skill building. So, if you're talking to teachers and they have students with a diverse set of interests, how can they make coding relevant to kids who are interested and excited about all sorts of things and maybe wouldn't name, coding on their list of their high interests?
Yeah. So the first thing I think is you can build anything you want with code, right? You can build Fortnite, a video game. You can build Facebook, a social network. You can build a finance app. You can build a pet, a pet tracker. Even one person I talked to very high up at Shopify, she just loved avocado. And we came up with that idea of learning how to code, building an avocado nutrition app. So you can go to, let's say, ChatGPT to go back to AI and say, give me 2 creative titles for an app that focuses on the following topic. And then you could say, for this app, what are the 3 top features it would have? And you can have ChatGPT basically create an outline for you of building an app that you really care about. And then all of a sudden now you're like, oh, I definitely want to learn how to code because if I can learn how to code, and you could be literally interested in anything at this point in time, right? Like snakes, right? If you really love snakes, you could build a snake app, right? If you love soccer, football, it doesn't really matter. I think that's what's exciting about code. You can build anything you want. So when you have students with diverse interests, just say, if you could build an app that's really deeply meaningful to you, it could be personal or professional, what app would you build? And what would be in it? And what if you learn how to code to build that app? How excited would you be?
I love those examples because I'm sure that someone who's listening right now can think of, maybe it's their 30 students, or maybe it's a student that they see once a week, or someone that they've connected with, right, over the course of their couple years, right, in a school building. And they say, oh, I know that kid is really interested in this, or I know this student is always talking about this problem they're trying to solve. So I think there's just so many ins for this conversation with students and all the different interests that they might have. So, can you tell us more about Hatch Coding, What does it do? How do people use this, right? How can they get connected to learn more?
Sure. So again, like I said at the top, there's a well-trodden path in mathematics, 1+1 to calculus. When I started hatch coding, I felt that did not exist in computer science. So I built out this 450-hour zero to engineer learning system. It's 4 certificates. It's 429 skills. And at the end of it, you have the skills to pass a junior developer technical interview. And so we take kids and we offer them one-to-one mentoring as they go through the program. And on average, the kids who finish take about 3 years to finish. Mm-hmm. So 3 hours a week for 3 years, or 52 weeks a year, 3 years. And we recently actually acquired a summer project from a University of Washington junior who was doing AI. So now we have another 450 hours. It's engineer to AI engineer. Mm-hmm. So if you have kids in your life, they're your kids or they're kids at your school, and you would like them to have more options when they graduate high school, Hatch Coding is where you can go to explore learning system and get the skills to pass a junior developer technical interview, either for engineering or for AI engineering.
I love that college and career readiness connection. They're reaching individual students who are expressing interest or maybe will become interested when they learn about opportunities like this one. So I will make sure for anyone who's listening right now to link out to all of the resources so they can click and go and explore. But for someone who's listening, maybe on the go today and making more of that mental bookmark, where can people go to connect with you and learn more about Hatch Coding and your work?
Okay, so you can go to hatchcoding.com/fall 2023 or hatchcoding.com/Monica if you want the special discounts. Either one will work. And you can connect with me on Twitter at P_Kuperman. That's KUPERMAN. And between Hatch Coding and my Twitter, you can learn more about me and the stuff that I do.
Well, thank you so much for your time today, for sharing these great ideas for educators who want to look at coding through a new lens.
Thank you so much, Monica.
This was such a great conversation, and I'm so glad that Peter could join today to help debunk some common misconceptions around teaching coding. So let's make this EdTech easy with a few key points from today's conversation. Help students determine their passion. Establishing your why is essential. AI can assist, not replace coders. Coding is for anyone and everyone who wants to try. Remember, you can find the show notes and the full list of resources from today's episode by going to classtechtips.com/podcast, and there you'll find all the ways to connect with the team at Hatch Coding. A big thank you to Hatch Coding for sponsoring this episode and igniting today's learning adventure. Hatch Coding is a zero to engineer learning system for coding starting as young as age 8, covering 450 hours of learning. Remember to visit hatchcoding.com/Monica. That's hatch, HATCH coding.com/Monica to get 50% off your first month. Hatch Coding, empowering tomorrow's innovators with the language of their future.